Hey everybody, this is Larry. This is me with Q3 of the weekly contest 316. Minimum cost to make array equal. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So I'm going to explain this problem in three different ways because the three solutions, well, two of them I've done, and one I'm going to try to do, well, I would say live-ish, but I have an idea. So we'll see if I get it correct or how long it takes for me to get correct. The first way I would say is using a ternary search. And here I kind of did a very sloppy ternary search, so do forgive me. But the idea here is that, and I'm going to try to paintbrush this real quick. I don't have my usual drawing array, so please forgive me for, if not, things are not perfect. But the idea is first noticing that this is going to be a convex function, right? So it's going to be something like this. Pretend I drew it better, but because I'm using the mouse, right? So my fault. But pretend this is, so this is basically what it looks like. It's concave. It is, it goes one way and then goes the other way, monotonically connected, right? So that's basically the idea. And here, I've actually seen the binary search solution, and it's actually very clever. But that's based on the fact that this is discrete. And even then, it technically doesn't always work. So you may get very, very unlucky in that if there are multiple answers, then you may hit 5 pieces and you may just be wrong on the binary search, right? So that's basically why, but, and, that's not the, I mean, you could do it and if it's ACs, right? But I would say that that's not something that I would recommend because, well, because it's just not right, per se, but also because it's almost like sometimes getting AC is may not be a blessing if you don't know how to do it correctly later, right? If you do learn anyway, then it's fine. And also, like my opinion about rating is that these are just kind of snapshots in time, right? If you get better, eventually it will go up to where it should be, right? Anyway, pretending. Let me actually redraw this a little bit. Let me just pretend this is a circle because that's kind of maybe not. Okay, fine. Let me try again with the thing. I'm doing it with the touchpad, so forgive me. Okay, so something like this, right? So basically, and you're trying to find, in this case, the minimum, which is here. So the idea behind this is that instead of like a binary search, and I'm not going to talk about this too much because it's something that, frankly, doesn't come up that much. So but the idea about the ternary search is that you divide them in dirts instead, and because of this, because that there's a sloping function, and because that the thing is going to be in the middle between these two, perhaps anyway. So that means that there's only 3 places, or there are only a couple of scenarios, right? So here, in this case, it doesn't matter which one you remove per se. You can remove this one, and you can remove this one, right? And then another scenario is that if let's pretend that it's not drawn to scale, and your dirts are here, right? Well, in this case, because of the way that it slopes, then that means that here is smaller than the other one, so you just get rid of this one, right? And then now you move the dirt accordingly. And of course, the other way is that if it's on this side, then that the slope will always draw you to this way. So the only case where it's a little funky is here, but in this case, it's okay to remove either one. So that's basically the idea behind the ternary search. I had some issues about implementation, but that was basically because I don't know, I just was thinking too much binary search. So I definitely had some issues with the implementation, but that's basically the idea. And I remember this idea during the virtual contest, and that's how I'm able to implement it from scratch. So I don't have any patterns or libraries or whatever fancy things. Let's get back to it let's get back to the code. I'm going to go over this code now, which is my ternary search code. It's not perfect, to be honest. There's probably a way to kind of be more very precisely correct, but basically this is way similar to the binary search, which is that we're just basically going we're taking the max, which is, so the number that is the answer that you want to change to will always be within the range, right? So that's my assumption here. And this is basically saying, okay, let's say we're trying to get to t. What's the cost? This is the cost. The cost is just, the difference of spaces as the move times the cost, right? And then you sum it all up, and that's pretty much it. And here, this is the ternary search code. It's not, I think you could be more precise, but for a contest, maybe it does an extra loop or two or something like this. So that's fine by me. And yeah, and that's pretty much it. And then this is basically doing that. And this assures that, and this is a hack that I do sometimes, but when I'm not very confident and when I'm in contest mode, I just want to get AC. Maybe I'll be more precise about it later. But again, basically, if this is greater than that, that means that the left side, it can be eliminated. Otherwise, the right side is eliminated. In the Leetcode case, it doesn't really matter. You just keep getting closer. And then the difference is that between this and the binary search, and besides the function that we have here to kind of demonstrate the visualization we had earlier, is that I just do a for loop in this case to kind of get the best answer so that I don't have to worry about off by ones. You could probably do this so that it is very precise, but I just don't want to deal with it. So here, this is going to execute like 3 times on just like left plus 1, left plus 2, and left plus 2 is right? So this should be good in that sense, because you could even add it to like say 5, without thinking about it. And what is the complexity here, right? Well, with ternary search, you could kind of prove it a little bit, but it's still going to be log n, I think. Well, log r actually, because where r is the range of the numbers. Because every time you shave off a third, right? So you go from 1 to 2 thirds to 4 nines to I don't know, I can't do math, 8 27s and so forth, right? So that is a logarithmic sequence, and of course the calculator function is going to be O of n. So in total, this is going to be O of n log r, and apparently it's going to be fast enough. So that's solution 1. Hopefully you understood that one. I didn't really go over the concept of ternary search per se, other than what I did, because I don't know that is that interesting or important. It doesn't come up that much, but it's just nice to have, and hopefully it's just good. But if you do want to study in more detail, obviously I think on the internet there are probably better videos for that one, so check those out. Just want to give you an introduction to that idea. And the second solution that I did, and I'll kind of also draw a visualization here. So let me bring back up the thing. Okay, so now basically this is the idea again. So now you have a curve, you have something that looks like this, and then basically what I do is that I calculate the cost at 0, which is, I guess, maybe this I calculate the cost here, right? And then every time the cost here, say, right? And then every time I move from left to right, there's going to be numbers that are moving closer to the number, and then numbers that are moving away from the number, right? What I mean by that is that, for example, let's say you have let me actually, I don't think this is a visual thing, but looking here, let's say you have something like, it doesn't really matter what the cost is actually, maybe surprisingly. Let's say you have this, and I'm gonna make up numbers. This is actually kind of a terrible thing, but something like this, right? That means that, let's say we go from 0 to 1, right? Well, what happens? Well, all these numbers move closer, obviously. And then now, let's say we're 1 to 2. Well, what happens? Well, actually, now 1 is moving farther away, where 5, 10, and 25 is moving closer, right? And then now 2 to 3, again, these are moving closer. This one is moving farther away, right? So maybe you could even keep track of it this way if you like, something like that. And then now, let's just say we went to 5. Then what happens? Well, 5 is even, but yeah, and then now let's say we go to 6. Well, now 5 is moving away, right? And while these are still moving closer. So that's basically the idea behind this implementation. Is this like, scan line type thing. And of course, each of them will have a cost, right? Because now we know that, I don't know, I'm just putting in random numbers. That means that for every increment of this number, we get further away by the cost of 2. Here we get away from the cost of 1, and here we subtract because now the cost gets lower because the 10 gets closer, right? So we subtract 5, subtract 2, but we add 2 and the 1 from the previous score. So that's basically the idea behind this problem, and yeah. And that's all I have for this one. So again, this requires the range, so this is going to be a little bit slow. There is some sorting of this cost so that I can kind of, for numbers that, this is just basically keeping track of numbers that move from coming closer to moving away. So that's basically the idea here, right? And this gives you the right answer. Unfortunately, during the contest, time limits exceeded, which is kind of very sad because if my logic was that, okay, look, it only does 1 million operation at most, but it does 1 million operation even for small n's. So I don't know. So maybe that's why. So if Leetcode had per unit, per input timing, this would definitely work. But I guess it doesn't, and it times out. But that's basically the idea. Starting everything off in the negative side, as in like it's every number is coming closer to you, and then whenever we see these events, every number is getting more positive to you. So that's basically the idea, and that's going to be O of R. This is going to be O of R, oops, plus and log n, right? Because we sort the inputs. Yeah, and everything is an O of 1, amortized. So yeah, I guess this is O of n, but it's not going to, technically this is O of n, but it's going to be dominated by n log n. Apparently this is a little bit too slow, and it's going to be O of n space, right? Yeah, so that's a little bit unfortunate, but there is a turbo way of doing it. I just, during the virtual contest, I just didn't want to do it because it is kind of, for me, very error prone, but maybe I could have done it, to be frank. Maybe I should have done it, and that's why I'm going to do it. The idea behind the turbo version is that instead of counting out, from 0, 1, 2, 3, what we have, the key observation here is noting that the answer has to be one of the answers, which I didn't prove during the contest, and I wasn't sure. I guess so, but one of the inputs has to be the answer. So the answer has to be one of the input, and then you just go from left to right checking which number. To be honest, I still don't know how to quite prove that, but apparently it's right. And the idea with that then is just doing it in a turbo way, meaning instead of going from 0 to 1 to 2 to 3, you go from 0 to 1 to 5 to 15 to 20, whatever the number that they give you in input, right? So here now then, reducing this n to O of n, which means that if you have a smaller n, it's going to be faster, and of course this n plus n log n is just going to be n log n. But let's kind of do this. I do want to use it as a practice. So yeah. So let's say now we have e and then maybe like now we have last x is equal to 0, say, right? So this is, yeah, last x is equal to 0, right? So then now let's say we have for xc in y, what do we do, right? Well, so delta is equal to last x minus last x, and then now we do this, right? Maybe it's not that bad, and I just kind of messed it up. And then maybe that's pretty much it. Am I being oh well, I have to update last x, so that would be really sad. But let's give it a spin. No, this is not quite right. I have to update this, and we update this by, we have to update delta n and delta y. So delta n means that this number yeah, minus C, because that means that for every time we process a number, has gone to the dark side. Okay, so that looks good. Let's give it a submit. Maybe I just need. Okay, so this one's on me. Maybe I should have just thought about this. I really thought this would be more trickier, and I was worried about off by one during the contest and stuff like this. But it turns out that what I had to do is change like 5 lines of code. So sometimes when you know so much, okay, that's going to come out of a humble brag. But you also saw other ways of me doing it. So I was very close, but it's not that I didn't know how to do it this way, because you just actually saw me do it. And this is me doing it fresh, like fresh as in like I didn't look up a solution. So this is actually pretty slick. But yeah, but sometimes, you know, and this is what practice gets you, right? Practice means that now you're able to kind of see these things in and kind of properly gauge which one you're able to do. And part of that, the gauging which one you're able to do is by practice, right? Because here I was so not confident about how to do this correctly that I kind of opt for some other thing, right? And also, to be honest, I should have done this to begin with. I was thinking, I mean, I knew how to do it and I was thinking about it, but I was just so worried that I didn't do it. So maybe there's a lesson there. But yeah, that's all I have for this one. I think this is, again, just is n log n due to the sorting. And in terms of space, it's just going to be n, right? So yeah, to you know, get the array or whatever. That's what I have, especially sorted. Yeah, that's all I have for this one. So let me know what you think. Pretty straightforward code, but I should have been better. Stay good, stay healthy. Oh no, wait. I mean, yes, you should stay good and stay healthy. But here's me solving during the contest. Next, inputs. But okay, got that one. Okay, minimum cost to make array equal. Okay, what does that mean? Nums and cost of n positive integers and to the following. Okay. And then the cost of doing one. Okay. Decrease one time. We have no decisions here, right? I'm just trying to. Oh wait. Or array equal as in. I thought A is equal to. Oh, this is cost. For some reason, I thought you're trying to make nums into cost or something. I've been very bad on the misreading. Okay, so. Okay, so that's a different problem. Let me reset my brain. Let's see, 10 to the 5th. Can we just brute force? Oh, not obviously not brute force. Brute force. Can we? Let's see. I mean, it's like a watermark algorithm type thing, right? You try for 1, you try for 2, you try for 3, and then. Because all the numbers have to, you know, should be. Does it have to be one of the elements? I don't think it has to be one of the elements, but actually, I think it might have to be. Not gonna prove that though. But yeah, I think this is like a event type sweep line type Eve problem, but it's just like very yucky to do. Okay, so all the numbers we can. Okay, the answer could always be 0, but though I guess it never makes sense. So we calculated for 0. So best is equal to, I don't know, some infinity. I don't know if that's big enough of infinity. Okay, and then we return best at the end, fine. And then now the cost of 0 is for x in num, in nums cost. We want that's just x times c. So then that's the total cost if we reduce it to 0, right? And then now we have events in which, okay, delta, yeah, okay. And also the delta is going to be just the sum of the costs. right? Okay, and then now we have these events. So we have zip nums cost. We want to sort it. Just sort it. This is fine. Is there an easier way? This seems pretty hard for Q3, but okay. And then we maybe just make it a deck because I'm lazy, right? Okay, and then now we just go for I in range of a million per. Is that too much? Don't know. I mean, it's fast enough for one. It's fast enough for one test case, but Leetcode is being silly to me, and I'm second doubting myself. So I just try it. Try to YOLO it, and we start at. Okay, so now we increment by 1, right? So that means that okay, while length of y is greater than 0 and y of, oops, how did that happen? And y of 0 is equal to I. While this is true, y of 0 of 1, so the cost, we want delta to sub. Actually, is that right? Oh man, I messed this up, didn't I? Well, this is the delta on one side. Okay, so there's two components. These are the things that if you get closer, it gets cheaper, right? So, okay, let's just do delta P and delta negative, maybe. Yeah, maybe the other way around, actually. This is, man, I am not doing well. Okay, if this is equal, then we actually if it is equal, then we don't add it yet, but of course do it before. Okay, right, and then now we subtract the delta n. No, this still happens first, so actually, so then the total minus delta n for going one closer to them, and then total adds delta p, and then now maybe this, because now we move one closer. But then the next one should be 0 though, right? I'm going to have an off by 1 here. But yeah, best is equal to min best of total. I think that's the idea. I think I'm off by 1 to be honest. But let's kind of at least see if I can get something close. 8 and 18 is... 8 is good, 18 not so good. Let me actually just print it out real quick so I could kind of visualize it. 1, 2, so we can make it to 2. Okay, that's actually right, but 18 is not. Did I mess this up? Why does it only go to 1? Okay, well, okay, but is it actually right? I feel like I'm off by 1. Let's just do this to like 20 just so that I can see the visualization. I've been having so many silly mistakes. I think if I haven't, I would be more confident at just submitting it. But yeah, so 0, 18, that looks actually okay. Because I'm worried about this order thing. I may be wrong, I don't know, we'll see. Okay, let's get back to 1. Okay, let's actually run it real quick first, and then let's give it submit. I don't know if I overcomplicated this, but it's only landmark n, so But then this one may be slow. Oh, come on. See, that's what I mean by Leetcode, right? Because this only takes like 1,000,000 operations. But Leetcode is just, I mean, it just means I have to be a little bit faster, and that's fine, to be honest. Like, I know how to do it. It's just I was hoping that, you know, I do it without needing it. Can I see how many cases I did? Is that a thing they tell you on, I guess they don't. Is this case monotonic, meaning that once we get increasing, I don't think it gets slower again. Is this a median thing again? Did I mess up? Or rather, this is a binary searchable thing, isn't it? Or ternary search at least? Because this is strictly... No, is that true? Yeah, it probably is. Because we just saw it, but still... Let's put it out real quick. Kind of see. It'll give me a output limit exceeded, I think, but we can at least see where the progression is. This is such an annoying problem. Mostly because Leetcode. I already got it. This is always out. I hate you. Okay, is that strictly decreasing? I guess so. Even then, it would take a lot of iteration. What is the answer again? What is the answer? I mean, this is ternary searchable, so maybe we just ternary search. I mean, I know that's the answer, but I guess I should have known. If total is greater than best, we return best. But that'll make it twice as fast, I suppose. Is twice as fast enough? I'm just lazy. To write the ternary search. Fine, we'll write the ternary search. Can we binary search? I don't know. Can we ternary search? I guess. This is just being silly. I mean... Rah, rah, rah. I don't even need all this then, right? Oh, you. Oh, Leetcode. Oh, you. What are you doing? I think I did that wrong, actually. But... I don't know if this is okay. If bit 1 is higher than bit 2, then we want to move left is equal to bit 1, else right is equal to bit 2. Okay, fine. I don't know, we might have some issues here, but that's fine. So depth calc of x for okay, just go T for target for x in nums. Okay, so cost is equal to 0. Absolute of x minus t times cost of okay, fine, enumerate now. Okay, that's clearly shadowing. That should terminate, actually. I don't know if it does. Okay, let's just add a... So there's this like thing I do. This may not... I haven't written the ternary search in a while. So it may not terminate because of integer division-y things. So here, then find inch of left, right plus 1. best is equal to min. I don't even update best anyway, so this is a lie. So so it doesn't work anyway. But wow, this is very slow. Maybe this isn't the way to go. Or maybe it's still time limit exceeds. 8 and 0. What is n? N is not that big, right? Why? How many loops am I doing? What? Why? What? Huh? It's a ternary search. And this is the absolute amount here that's causing it. Wow, I'm just confused now. What is going on? TLDR seems to be that I hate Leetcode though. Did I mess it up? If they're Ucode, then doesn't matter, yeah. Huh? Honk. Okay, let's say I don't have this. This is right at least, right? Okay, and this way, I don't know if I would consider it fast, but oh no, because it just does a for loop for under 10 elements. Why does this terminate time limit exceed? It's just 10 to the 5th is 100,000, right? Okay, now I see. Tell me why. Huh, it is looping infinitely, but why? Left is equal to... Did I do the ternary search wrong? Left, right, I guess I did do it wrong, huh? Yeah, it's been a long time. That's 1/3, that's 2/3, right? Why is that wrong? I am dumb, am I? Okay, so this... Maybe something like that. It's been a while. Okay. That is not that much faster though, unfortunately also, so we'll have to see. Well, also print a lot of things, so maybe that's why. It seems not even faster than the other one, but let's kind of see. If time limits again. Am I just doing a silly thing? Okay, I don't know what to tell you. Though I did do the... It's a good practice on a ternary search. I still hate it. My first solution should have been good enough. All it does is a million... Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, anything in between. I'll see you later. Stay good, stay healthy, to good mental health. I'll see you later. Bye-bye.